Okay, so what we need is a regular pentagon with radius 6 centimeters. We're just going to do this. Pentagon, where are you? Okay. Good. So what we do every single time is we break it into the radius, and then we look at just that triangle inside. So we'll look at the bottom one. We realize to get the angle right here, that would be 360 divided by 5. And that equals 72. So this is 72 right there. And then what we do is we cut that bottom one in half to find the apothem. So and that would be 36. So let me redraw this real quick. 6, 6, 6, 6, 72. Good. So this would be 6. This would be 90. And then what adds with 36 and 90 to equal 180? And this would be 54. Cool. So what I need to do is recognize what I know. I know that the area is equal to 1/2 times the apothem times the number of sides times the side length. I know the number of sides. It's a pentagon, so it's 5. It's 1/2. But I don't know the apothem. That would be this. I'll call this A for apothem. And I don't know the side length. And the side length would be this whole thing. So we need to first find, we'll say this is X, which is half of the side length. Now, if we use 36 as our angle of interest, X would be the opposite side, and the apothem would be the adjacent side. If I want to find the apothem first, I recognize adjacent, and I know the hypotenuse is 6. Adjacent and hypotenuse is the cosine. So I say the cosine of the angle equals adjacent over hypotenuse. Cosine of 36 equals adjacent, A, don't know it, over hypotenuse, 6. Multiply by 6. Sorry, you guys like to cross multiply. Let me do it that way. So 6. This is over 1. So take 1 times A. You get A. 6 times the cosine of 36 is 6 cosine 36. Six times the cosine of 36 equals 4.85. So I just found my apothem, 4.85. Now I need to find my side length. I need to find the opposite first, and when I do, I multiply it by 2. So opposite is X, hypotenuse is 6. I know my opposite, don't know my opposite, need to find it, but I know my hypotenuse. So opposite and hypotenuse is sine. Sine of the angle equals opposite sine of the angle is, well, we're using 36 as our angle. And opposite is X unknown, hypotenuse is 6. this over 1 so we can cross multiply. 1 times x is x. 6 times the cosine of 36 is 6 sine 36. And I get 3.52, but I have to multiply that by 2 to get the full side length, which is 7.05, all the way across. So now I have the last piece of information I need, and I can calculate that all out. Multiply that out, you get 85.48 square centimeters. Okay, so area of a triangle given 2 sides and the angle in between. The area is equal to 1/2 times those two sides times the sine of the angle in between. In this case, we're given sides of 104 and 226. So that would be our B and our C times the sine of 40, our angle. Multiply that out and you're done. One half times 104 times 226. And then sine of 40. You should get 7,554.04. That would be square meters. Circumference of a triangle is equal to 2 pi r. If I know my diameter is 14, then my radius is half of that, which is 7. So 2 times pi times 7. Leave it in terms of pi. 2 times 7 is 14 pi. That would be square inches. No, sorry, just inches, because it is just circumference, which is a length. Move this to the next page so I have more room. Okay. The arc length is equal to the circumference times the ratio of the angle to 360. So basically the portion out of 360. In this case, I have 45 right here. And then I have another 180. Add that up. Equals 225. So that is my angle. All the way around, 225 degrees. I know my radius is 4.1. So I plug it into my equation. Arc length is equal to the measure of the angle over 360 times 2 times pi times r. The measure of the angle is 225 over 360 times 2 times pi times the radius of 4.1. We want to leave our answer in terms of pi, so multiply the fraction 225 over 360 times 2 times 4.1. And you will get 5.125 and tack the pi on at the end, and that is a length, so that is just going to be in feet. Cool. So with this one, we've been given the radius is 12 and it's a 60-degree arc. So that's all we need. Arc length equals the measure of the angle over 360 times 2 pi r. This would be 60 over 360 times 2 pi times 12. Multiply just the numbers, not the pi. So 60 over 360 times 2 times 12 equals 4. Tack the pi on at the end, and that would be in centimeters. Area of the circle is equal to pi times the radius squared. In this case, we aren't given the radius, we're given the diameter, but that's half. The radius is half of the diameter, which is 3. So, area equals pi times the radius of 3 squared. Leave our answer in terms of pi, so we're just going to take 3 squared. We get 9. Plug the pi on there, and that would be in square meters because it's an area. Area of a sector is the portion out of 360 of the angle times the actual area, the whole area. So if we have 120 degrees right there, and we know the whole thing is 180, then this would be 60. So the measure of the angle over 360 times pi r squared. Measure of the angle, 60 over 360 times pi times the radius, which is, well, the whole diameter is 26, so the radius would be 13. Leave answers in terms of pi, so multiply everything else out. And you're going to get 28.1617 pi. And that would be in square meters. And then the final one. If you know the area of the sector, subtract the area of the triangle and you will get the area of the segment. So, we know this sector has an angle of 60 degrees because the vertical angle is 60, so they should be congruent. It has a radius of 6 meters. We need to find that little sliver, that little segment. So, area of a sector is equal to the measurements of the angle over 360 times pi times the radius squared. Area of a triangle is equal to 1/2 times b times c times the sine of a, the angle. When we find these two quantities, we will subtract them. The measurements of the angle is 60 degrees. Pi times the radius of 6 squared. Multiply that out, and I'm actually not going to leave it in terms of pi. I'm sorry, guys. I'm scratching this out. And you get an area for that sector of 18.85. Now, to find the area of the triangle, I realize that both of these sides of the triangle are 6 meters. And the angle between is 60. So it's going to be equal to 1/2 times 6 times 6 times the sine of 60. And you should get 15.59 for that area. When you know the area of the sector and the area of the triangle, subtract them and you get the area of the segment. So we take 18.85 minus 15.59. And you get an area of 3.26 square meters. And then you're done.